Hello, and welcome to today's SEI webcast, AI Next Generation Architecture. My name is Shane McGraw, Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make our webcast as interactive as possible, so you can address or you can put your questions into the YouTube chat area now, and we will address as many as we can throughout today's presentation. Our featured speaker today is Mike Matarock. And Mike is a technical director within our AI division here at the Software Engineering Institute. He collaborates with organizations to evolve and expand mission-critical capabilities related to national security. Prior to joining Carnegie Mellon University, Mike held various leadership roles supporting the research, deployment, and sustainment of evolving technologies across the federal workspace. His work focused on digital transformation, autonomy, open architecture, cybersecurity, data science. Mike, welcome. Thanks for joining me today. We got a worldwide audience for you. I saw in the chat we got folks from Spain, Guatemala City, New York City, Maryland, Washington, D.C. So they're all here to hear you. So all yours.
Excellent. Thank you, Shane. Well, welcome, everyone. I'm really excited to spend some time with you this afternoon as we dive into this concept of next generation architecture with particular attention for artificial intelligence. It's tough really across society nowadays to not encounter artificial intelligence somewhere in our daily lives, as it really permeates across industries, and in particularly as we continue to see in the national security space across our mission partners and across a lot of the efforts and capabilities that we need to safeguard our country, both domestically and internationally. And so very excited to talk about this with all of you. And great to hear that we have worldwide participation in our audience today. Just as we get started, I really do think that given all the timeliness and change that we see throughout the world today, it really is exciting to talk about this pervasive influence of AI throughout society. Just take, for instance, the provocative ChatGPT that has already garnered over 100 million active users just in the first 2 months of its launch alone. It's really an incredible feat, especially when we think about other technologies that have evolved, encountering that kind of user base that quickly, that has so many diverse stakeholders involved and so many different users. Again, it really is hard to find an aspect of life today that hasn't been impacted by AI. From the goods and services that may be in our homes and offices that we rely on, to transportation, both private and commercial, and even the recommendations we're provided with on a regular basis from platforms like Netflix and Spotify. AI is there. It is a part of our daily life. And as we navigate this journey of AI and its implications, particularly in the mission space and national security, we'll talk on these couple different topics today. So I first want to spend a little bit of time just talking about the role of AI engineering and having a working definition of what that is, how that can really guide some of the different initiatives and investments that we see across the DoD, the intelligence community, and really across industry as well. Then I want to spend a little bit of time on just AI today, its current state, where we're at in terms of some of the challenges and constraints that exist, and then talk a little bit about how we can solve some of those challenges and constraints as we engage in new development, consider new designs, and employ new capabilities for the warfighter and beyond. I think it's also important that we spend a little bit of time on just some general awareness and considerations. So it's very important that we understand the work that we're doing as we engage in machine learning and other subsets of AI, particularly when we consider things like biases and how to have ethical use of AI. What are some of the things that we want to do and some of the things that perhaps we should avoid as we take lessons learned from industry and other implementations rather, that have been launched. I then want to shift gears a little bit, and we'll jump into more of an architectural view, just understanding the level of where we're at for the discussion today. We're definitely going to be more at the reference architecture level, and we'll dive into a little bit about what that entails and what that means as we start thinking about different architectures and how AI can fit in to the work that we have existing across current state platforms, and as we start thinking about this idea of a next generation architecture concept and what the implications could be there. And of course, we can't have a good conversation on AI without consideration for data, particularly data ops, and some of the strategic considerations we need to have around data that feeds a lot of these systems and solutions that we'll have. And then I just want to conclude our time together today talking about the concept of an AI next generation architecture, as well as some of the principles that really go hand in hand with such a concept and that kind of mechanism. So definitely, as Shane mentioned a little bit earlier, I want to reiterate, we're happy to make this an interactive experience. So definitely welcome questions that you have throughout the briefing and any kind of follow-up that you have as well. I'm happy to have those discussions and talk about this topic. So as we get started here and just thinking about this idea of AI engineering, and its simplest form, AI engineering is really a mechanism to ensure that the efforts and investments that we make around artificial intelligence are done so in a consistent, responsible, and advantageous manner. The discipline itself focuses on developing tools and processes, as well as frameworks and systems to enable the application of AI in real-world situations and applications. We have a lot of great work that continues to take place across our campus here. CMU continues to be ranked #1 in the world for artificial intelligence. And AI engineering is one way that we're able to harness a lot of that goodness that our experienced and seasoned researchers are engaging on and allowing us to be able to capture those capabilities and ideas for actual mission scenarios that we have, particularly for our mission partners across the DoD and the intelligence community. You'll see some of the questions that we seek to answer here are unlike many of the service offerings that are available today, particularly if you're talking to folks in industry that are looking to sell a solution or really try to bring the shiny object into the room. AI engineering does not seek to focus on those kinds of considerations necessarily, or chasing the latest and greatest technology, but rather zeroes in on some of these questions here, such as how can AI help humans achieve mission outcomes? We want to be cognizant of, we're not talking about a Terminator style environment here, whereby robots control the world, but rather more of an Iron Man kind of concept if you're a movie buff like I am. How can we really focus on elements like human-machine teaming, making sure that human-in-the-loop concepts materialize and resonate with the work that we're doing? We also want to make sure we pay particular focus on what are the limitations of AI in practice today. We recognize that we have to still have human decision-making process involved in most of the work going on in the current state. There are a lot of claims of full autonomy, and we can talk a little bit about that in a later slide here where we dissect some of that ambiguity that exists around autonomy and AI, for instance, and just what autonomy really means in that kind of sense. And we also want to seek to answer the question of how we can ensure the ethical standards are upheld as AI systems deployed. I think this is really important. This is where we see in a lot of the experience that we have as the Software Engineering Institute, mission partners that maybe have some reservations about this blanket topic of artificial intelligence. There's a lot of considerations we need to make. And responsible AI as a term is something that has become more prevalent across conversations in this space. How do we make sure that it isn't just an afterthought, right? Similar to our approach whenever we began our journey in cybersecurity back in the late 1980s, how do we make sure that responsible and ethical solutions aren't an afterthought, like cybersecurity isn't an afterthought in our design and development today? We want to make sure that that is a thread that exists throughout the life cycle from ideation through sustainment and maintenance. And so we'll spend a little bit of time talking about those areas as we become more familiar with AI engineering. Again, the discipline of itself really seeks to provide that framework and tools to proactively design AI systems and solutions. And we want to have this lens for functionality in complex, ambiguous, and dynamic environments. So an example of what this means, we could have a great sensor that's used in an object detection mission that has been developed in a lab. And that sensor could operate very well and produce impeccable results in terms of being able to identify, say, a particular entity like a tank. However, when that sensor is deployed in the real world and it encounters different variables like weather and sand and fog and other variables that exist that are without our control, how well does that same sensor function? And in many instances, we see for rather immature solutions, it doesn't. It fails, or the results are lackluster at best. And so the idea of AI engineering is to ensure that we have that robustness baked in from the get-go. And we're thinking about solutions that aren't just artificial and surfacey in nature, but rather able to withstand rugged environments where they can encounter different variables and ensure that we're able to achieve the objective that they're set to achieve. So this includes making sure that our practitioners, our engineers, our technologists are equipped with developing systems across the enterprise to edge spectrum, that changing environments aren't a peril to the solutions that we develop. And we want to ensure that the human element remains indeed there. So thinking about things like all stakeholders involved and who's going to use the solution, as well as those that are going to be in a position to make decisions based off the outputs of that particular AI solution. One comment I'll also make here that's not on the slide, but I think is equally as important. AI engineering isn't just for the technologists and the engineers in the room. AI engineering as a discipline really looks at being multifaceted and incorporating all stakeholders. So our acquisition professionals that are out there that are going to be looking at bringing in these kinds of solutions and entering into agreements are just as important as those that are actually developing and employing them. I'll give a quick anecdotal example of that from my time in government. Numerous times, the government encounters situations where we don't have access to our data. We don't have the data rights to be able to see the data that a vendor is actually using because of the way our acquisition was structured. And so it's paramount that as we encounter new AI solutions and new acquisitions take place, that we're being cognizant of some of these considerations up front. So that way our acquisition community is able to enter into agreements with the best interests of the government at mind and not falling victim to some of these situations where we don't have access to critical needs, such as data for systems and so forth. So you might be wondering at this point, why do I need to worry about AI engineering? I can just jump in and create my AI solutions as I go, right? It's a lot faster, it's a lot quicker. I don't need to follow a particular set of framework or tools. And while that can be the case, one of the things that we do see quite a bit here is the rate of failure. And so this slide starts to demonstrate that need for AI engineering and why it is important when we think about things like failure. There's a statistic that's out that Gartner released not so long ago here that's to the right of the screen. And by 2025, the 10% of organizations that establish AI engineering best practices will generate at least 3 times more value from their AI efforts than the 90% of organizations that do not. And I share that statistic just because I do think there's some profound impact there. If we're not approaching our investments in artificial intelligence from a consistent place and really having the mechanisms and evaluation framework in place to evaluate consistently and be able to think about tenets like modularity, reuse, interoperability, and integration, we're really setting ourselves up for failure in a number of ways, particularly when we start thinking about the considerations of scaling those solutions to meet the true demand of our organization. Whether that's in a mission space, whether that's in a safety critical space, there are a number of different environments in which that truly is paramount. One other repository that I'll just point folks to that's here on the screen in the upper left is the AI incident database, And just sharing this because we only have about an hour together today, and there are numerous situations that are detailed here, particularly from industry, that show instances where AI was not effective or caused additional issues that evolved. And I would recommend that as practitioners, as technologists, and as leadership, you take a look at some of the different aspects here to really understand some of those instances. One of the examples that is contained in that repository comes to us from Amazon, who a couple years ago wanted to automate their hiring processes and developed an applicant tracking system that automated a lot of the review of resumes. One of the biases that was built into that design, unfortunately, was the screening of female candidates outside of those candidates that were called to interview. And so the resumes that reached the hiring manager, that reached HR, were those from male candidates. And there were a number of instances that showed where attributes were not able to be selected for female candidates. And obviously, that's not an environment that we want to have. That's not an effective solution. And Amazon has done a great job of really showcasing that due diligence that's needed as we think about biases. I think on that note, a bias is going to exist in the solutions that we develop. It would be really silly to think that that's not the case. However, how we mitigate that bias and how we understand and can explain that bias is what's really critical. Just by human nature, all of us have a bias to one another and in different aspects that we look at. So we want to be cognizant of that as we get into some other pictures. And then finally here, just the mention of ChatGPT, a timely topic for sure, and some different academic issues that arise with that. I always get a kick out of some of the different things you can see on LinkedIn and other platforms where there are students now that have 3D printers that are connected to ChatGPT that are actually writing their book reports for them. So again, another consideration that we really have to think about. Perhaps those are folks that we should be trying to recruit here at CMU, but anybody that's in middle school or high school that can think that far ahead truly impresses me. But there are considerations of that as well, right, that we need to think about and be cognizant of as we engage. And AI engineering, in a lot of ways, is that mechanism to help us think about. I'll just conclude here. If the case wasn't strong enough yet, I think this topic of ambiguity that exists is very pervasive around artificial intelligence, autonomy, robotics, analytics, and data science. Unfortunately, we hear a lot of these terms used interchangeably, and they're not. They are different. While there is consistency and similarity to some degree across some of the areas, and in many ways, artificial intelligence builds on prior knowledge. It is important to recognize that these are different concepts, they're different disciplines, and while they can be interrelated, they are separate in of themselves. So how do we think about AI? Again, many different definitions that are working out there. Also understanding just how we can have common vernacular. That's where we think about things like a body of knowledge concept that can really help stakeholders across different platforms think about these topics and be able to execute common goals. That's one of the tenets that we're going to hit on with our architecture discussion in a little bit, is just that idea of establishing a common vocabulary among diverse stakeholders. So that way people don't talk past one another and we can be on the same page when we talk about these paramount concepts, particularly as they transform the organizations and the capabilities that exist today. It's also worthwhile calling out there are a number of ways to assess maturity. And I think one of the areas that we're starting to see a little more traction is in this idea of metric development and evaluation. It's not enough to just develop an AI product, right? We want to have a return on investment mechanism that we can use to measure. We want to understand how effective that product is and how effective its outputs are. And that's where we have to spend quite a bit of time around uncertainty quantification. Take, for instance, a soldier that's in the field that may rely on a fellow battle buddy to be able to make a decision. And as human beings, we have different qualifiers that we use in our vocabulary that really help us understand the confidence level that our fellow mate or partner is trying to tell us and convey. For instance, I might tell you, I'm pretty sure that a train's not going to go by and you're going to hear the train whistle because of the time of day. And for those of you that heard it, it was just a little bit ago. So make that kind of tongue in cheek. But the case being, there's that qualifier there of pretty sure. When we're starting to talk to technology and having that human machine teaming element, we don't necessarily have those kinds of qualifiers that we can rely on in the decision-making process. So it's very critical that we have tenets like uncertainty quantification to be able to give us a measure of understanding the confidence level of that output. Take, for instance, what we all might be familiar with on Netflix, right? We get a 98% match on a particular series or movie that might come out. That's pretty important for us if we're worried about time and so forth and what to watch, but arguably far more critical if we start thinking about a weapon system and we start thinking about national security implications when we're relying on a similar output to give us the confidence to make a decision on what to do. And so that's critically important. That's a theme you'll see throughout, particularly as we talk about the architecture. That's really important to ensure that we do have that kind of confidence level and we can establish that trust that exists between the human and the machine. And then finally, we'll talk a little bit more about this idea of siloed projects. You know, really doesn't convey much good, but sadly is commonly an occurrence that it has existed and continues to exist. AI engineering really seeks to try to bring about those diverse stakeholders together to be able to convey repeatable solutions that are integrated and can be used throughout different environments. So just highlighting here some of the challenges and constraints some of you may face today. It's something that all of us encounter on some degree basis, particularly as we jump into the subfield of machine learning. Models are trained in silos by different teams and typically without comprehensive data sets or curated information. And why that matters is when we think about as human beings how we learn, in many cases, our knowledge is built on prior knowledge, right? For instance, if I was thinking about how to ride a bicycle, I need to be thinking about balance before I even get on that bike. And perhaps that's a lesson that I learned earlier in life. As we're training different machine learning models, the same holds true, is that how do we start thinking about different ways to be able to train that model with information that might already exist within our enterprise that we already have data for, without having to recreate the wheel, so to speak, and start from scratch. So ensuring that we're able to have that comprehensive information, particularly if we just made a significant investment on developing a model and in going through the painstaking process of curating and labeling that data for ingestion. So a problem that continues to exist that's nothing new, fusion of data sources. This is something that has existed for quite some time, however, is becoming increasingly important as we start thinking about data being the fuel for which a lot of our machine learning models and really AI by and large functions. So it's important to have more of those comprehensive data sets that are able to give the context and the awareness that we're looking for as we develop these solutions. Overfitting and underfitting of models, something we encounter quite a bit. And how do we have that kind of differentiation that we can use to ensure that we're developing effective solutions that aren't encountering those kinds of problems down the road? And a lot of that requires the upfront preparation of data. Training intent. I hinted at this just a little bit ago, this idea of single task training versus multitask. And how do we try to focus on solutions that are able to be robust and build on prior knowledge in order to ensure more comprehensive outputs in decision making? And then finally, we also want to focus on the speed of training. Training right now is typically a very manual and in many ways lengthy process. We want to get to a point where we can really automate some of the work that requires, particularly when we think about some of the work we're doing right now at the SEI around automatic target recognition, and how we can really equip some of our different aspects and research products to be able to rapidly train as opposed to taking days, weeks, months. How can we start thinking about that more in hours and minutes? And so just the punchline here, I would say, some of these old challenges still persist, right? We still have the fusion of data sources that we need. We still have the rapid development that's important and has always been the case, but we do have some new constraints. There are caveats to things like the fusion of data sources, because now for the first time, we might be seeing really strange multi-domain data formats. We might be trying to take OSINT information, open source intelligence from social media platforms that's coming in a variety of different data formats, and marrying that up with some of our signal intelligence data that exists in a specified form. And how do we start looking at that integration across a myriad of different data formats in order to have this common understanding and awareness? As we start to think about our architecture concept, I think it's important to spend a little bit of time just defining the term in of itself. And the SEI is no stranger to architecture whatsoever. In fact, a lot of our work has focused on this over the last few decades in the software space. We're not going to really hit on software architecture today so much, though there are a lot of considerations that we can take and use in the artificial intelligence area. But just know that those software architectures do not go away. They're still important. The quality attributes that are associated with them are just as relevant today as they ever have been. As AI becomes more focused in on the capabilities that we use and automation becomes a bigger part of our day-to-day environment for mission capabilities, the prioritization of some of those attributes does change. However, the fact that they are identified and still a part of our work does not. The architecture construct really serves the purpose of making sure that diverse stakeholders are able to speak to one another. It really is that dynamic mechanism that can be used to serve as in a number of ways of establishing common frame of reference. If we have an architecture that we can use, we can usually pinpoint different subsystems, different data flows, different pipelines that exist to be able to understand the product better. Architecture also influences our quality assurance in known ways. Unknown ways, that's a different exploration that needs to take place and requires a different level of scrutiny. But the ability to influence our quality assurance in known ways is really important and something that architecture helps us to do by having that comprehensive view in a number of ways. It's also pretty important to have in terms of change, which right now I would argue that probably everyone on this call, everyone on the line is going through at least some level of change within their organization. We have different campaigns like digital transformation that are taking place. We have different areas of automation that are taking the place of some manual processes. There are a number of different changes that are taking place, and architecture allows us to have a mechanism by which to manage that, and is really important when we start looking at it. It also allows us to pair communication with analysis. So again, to that idea of having a common vernacular, if we can talk with one another about these different tenets and these different aspects of a system or an overarching enterprise, we're able to put together much better analysis and understanding the constraints and the dependencies that exist, as well as maybe some assumptions we might want to make as we're designing and developing new solutions. And then finally, acting as a reasoning instrument. I think another critical aspect that we want to have as well, we want to make sure that we're able to reason good solutions and develop good decisions that we have both from the investment standpoint and in our day-to-day use and functionality of the system or the solution that we're talking about for the architecture. So that kind of tees us up, and you might be wondering at this point, well, what architecture are you talking about, Mike? Where are we at here? There are many different levels of architecture. I've heard some of these different concepts before. They might be familiar, they might not. What I want to say for the purposes of today's discussion, we're going to really focus around a reference architecture. And that's arguably the highest level of an architecture that we would have that traverses the three different common architectures that you might encounter in your organization as shown here in the graphic. Reference architectures typically are standardized architectures, and their existence is to provide common reference for a vertical or a domain sector. You can think of them in a way as guardrails. They're really the guardrails that exist to keep effort on track. They're not solution architectures, and I want to make sure I'm very careful of that. They don't implement directly. They're also not segment architectures like you see in the middle here in terms of focusing on a particular domain. And they're also not at the top level here an enterprise architecture, which is typically a mechanism that allows us to make good investment decisions around IT and really that marriage of business and technology. The reference architecture really is more of those common principles, those common guides that allow us to think and flow on a particular instantiation across many different architectures and solutions that exist.
Mike, can we take a question or two here?
Absolutely.
The first one asking, are there new cross-cutting concerns as we think about data reference architectures?
Yeah, that's a really good question. And one of the aspects, I think we touched on it very briefly, but this idea of responsible AI. So that's an area that is new in a number of ways that we have to think about, particularly ethical use. So how do we make sure that the different initiatives that we're a part of, especially as we start thinking at this broader brushstroke of reference architecture, are engaging in a responsible manner, that are taking some of the tenets that exist for ethical use, that are making sure that to the best of our abilities, as it makes sense and is appropriate, our solutions are mitigated of bias. What do those aspects look like that we didn't necessarily think of before when we were developing software solutions? It wasn't as predominant of a priority, I will say there. And that is something that I do think is a bit of a change in our artificial intelligence approach.
And Mark was looking for a little deeper dive on the fusion problem, but I do think you touched on a little bit more since he made that comment. But I don't know if there's something else of the fusion problem that you can throw in at this point.
Yeah, absolutely. We'll have a little bit more of a visual representation in a few slides just around the architecture, but one thing to comment on, it is a difficult challenge that we encounter, right, across many different disparate organizations, this data fusion piece. Because as we look at model development, we have to be cognizant of what that model's ingesting and what the familiarity of the algorithm is able to identify. And that requires, in most instances, to have a common data format. And so when we're bringing together all of this data that exists across the ethos in different ways and is collected in different mechanisms and is organized in different ways, that becomes quite a cumbersome dilemma. And there are solutions out there. I'll just share kind of off the side, sometimes this black box magic that permeates in solutions that claim to be able to capture all of these different data formats and package them up in such a way that delivers value. In a lot of ways, those solutions do fall short. So we do have to be cognizant of all of the different aspects that exist of data out there, particularly as we fuse. And on the data fusion comment, we'll see in an example related to an avionics architecture, how important that has become with artificial intelligence.
Next, Henry asked a general one, and this question stemmed from the abstract that we sent out. So this may be something you're covering later, Mike, or we can address it later if it's not relevant right now. But he asked, the learning points don't list approaches to testing AI. To testing AI, the speaker mentioned that diverse operational environments can cause problems. Thoughts on the state of AI testing as part of the architecture?
Yeah, that's a really good question, and honestly, that could warrant an entire discussion itself. I'll say one reaction to that is very much this idea of establishing test ranges. It's not enough to look at testing and evaluation just in the lab, right? We really need to be cognizant of those variables and environmental factors that exist that are outside of our control. So if we're going to have that rigor of AI engineering, we want to ensure that with that comes the testing and evaluation necessary to ensure robust and effective solutions. And in so that regard, it will be different organization by organization and just understanding the mission or business space, if you will. But that is a critical piece that we need to be able to look at, is the testing and evaluation of our solutions, and having a consistent framework. That's something here at the SEI that we're continuing to develop. There are some tenets that exist out there from software engineering and from cybersecurity that allow us some good principles to follow. We also have to think about some of the new ones that exist, particularly around human-machine teaming and responsible AI, and some of the other considerations that we want to have in there as well, depending upon the application, of course.
All right, this is the last one. We'll catch us up for this section, then we can move on, Mike, after this one. Doc asks, where do we address legal issues in our model for AI development and deployment?
Oh, that's a really good question. And I think that That in a lot of ways goes back to the idea of responsible AI existing throughout the life cycle of development. I think if we wait till the end and we wait until a solution is developed and we start thinking about the legal concerns and the ethical implications, we're probably in trouble. Because our AI solutions are in many ways built on prior foundations, we need to be cognizant of those thoughts and mindful of things like legal compliance upfront. What does that mean, right? So if we're thinking about data that's being ingested by a particular machine learning model, we need to be cognizant of where does that data come from? Is the data collection process or mechanism in compliance with the laws and regulations that govern our particular organization? Because if it's not, we're already going to be at a disadvantage and perhaps out of compliance or out of law upfront, just with the data that's being ingested by that model. So I do think that that's something that we have to look at across the different phases of the life cycle, and not something at the end, which sadly many times now, as we see in the current state, is kind of an afterthought and something that's thought after a proof of concept comes out. And we start to look at fielding that into a sustainable solution. That is a really important consideration, and I'm glad that question was asked because it is an important point that I don't think we really spent too much time on today so far. So I'm going to transition gears a little bit. We started this conversation around a reference architecture, and I'm going to spare you from the principle-based approach in my former life as a logistics reference architecture guy, talking about reference architectures in general, and really start to zero in on our topic at hand today. Data reference architecture, and this is just a simple example of what a data reference architecture can look like from some of our earlier work here at the SEI, as we start thinking about a big data environment and service providers that exist there. A couple things that I kind of want to hit on here. A good data reference architecture exhibits some of these different characteristics. It defines the requirements, architecturally significant requirements, and really is able to identify some of the trade-offs that are affected by different types of requirements that might exist. It develops and evaluates solutions. We want to make sure that our reference architecture is able to realize a particular capability. In this sense, it's looking at being able to have that collection, sorting, and processing of a large amount of data, potentially petabytes of data that could be existing here. And then a third characteristic that our data reference architecture definitely should exhibit is this idea of integrating systems together. So we recognize that across enterprises, across organizations today, there are existing infrastructure. There's likely existing reference architecture that's out there in different modules. And we want to be able to seamlessly integrate as best as we can and assess conflict as it arises using the architecture mechanism. In a lot of ways, this is where we start to see things in the federal space like GRAs, government reference architectures, and how they integrate data and information and different boundary conditions and roles that may be used to describe a particular mission capability needed by the warfighter, and enough detail to allow for that transition to a solutions architecture, where you're actually starting to look at the technology-based solutions and implementation layer of details that's contained in there. I just want to leave four kind of themes here before we leave the data reference architecture example. Real-time data processing, that's something that we continue to see to be a little bit of a challenge in many ways, but also something that's really paramount in our development. The need for modular platforms. Modularity is huge and is in fact one of the AI principles we'll kind of conclude with today as we talk about an AI next generation architecture. And then two other elements, decoupled data access and what that looks like, particularly as we start thinking about computing on the edge and being able to access our solutions from potentially anywhere in the world. And then also extensible data schemas, getting past just XML data schema, but also understanding the different interaction and interoperability for different kind of message formats, different kind of data types, and what that looks like. So this idea, if it hasn't been clear yet, I hope this slide really brings it home. We have to enable AI for data consumption. And what does that look like? So obviously, curated data is an integral element to enabling AI. I think of one of the questions we typically ask of our mission partners as we start an engagement: what's your data like? It's usually not, do you have data, but what's your data like? Do you have curated data? Is your data labeled? A lot of these different components exist to really aid this requirement. And there are some different ways that we can get at it at the organizational level. Different mechanisms like canonical data models. This is particularly important if we have an organization that has disparate data formats, which most do, and allows us to have that reconciliation of different data types across an area as we start to think about data fusion and other ways to really build out our models and so forth in the machine learning space. Integrated logical and physical data models. Another area there too. I won't go down the DODAF rabbit hole just yet of looking at some of our different viewpoints and really how those physical and logical data models can help. But again, ways to really get an organization on the same page to understand how their different data sets fit together in building this more enterprise comprehensive view. Master data management, that hasn't gone anywhere, right? That's something that's been around for quite some time. It just becomes increasingly important. Just like some of these other areas. It's a topic we need to focus on, investment we need to make up front if we're going to have effective and sustainable solutions. And then finally, data labeling and just the overall cleansing and mapping of our data. Again, not necessarily new topics, but new priority on these because it is so critical to have good data that is well cleansed and well connected as we develop our models and algorithms. I don't know that I would be doing a good service if I didn't bring up data ops at this point. But surely a lot of folks on the call have probably heard things like DevOps and DevSecOps, and now you're hearing data ops. And what in the world does this mean? Do the other ops go away? How do I prioritize this? And the answer is no, the other ops don't go away. In many ways, data ops is complementary to DevOps and DevSecOps and other correlated methodologies. What we mean by DevOps is this collaborative data management practice. Think of it as really bringing in folks together that have different needs, different roles within the organization, and the focus is on improving the communication, integration, and automation of those data flows between those that are in development and management and those that are consumers within an enterprise. So we have our data mission and technology personas brought together. Really, all stakeholders are included here. This is a strong inclusivity that we want to have, just because as we have those diverse perspectives, we're able to really make good solutions and really focus on the good state of data, if you will. Data engineering is also an important piece here. We want to make sure that we're doing good work up front so that we're able to realize those benefits down the road. And data ops as a mechanism to automate deployment. That's definitely a big consideration, particularly as we start getting into some of our automation and autonomy considerations, because it helps for that seamless flow of our processes in data collection, data analysis, and then infusion of that data in later products. As we start thinking about bringing all of this together, I think it's important that we spend a little bit of time around some of the guiding attributes of AI engineering. And we have 3 different ones here. I'll run through these briefly, and then on the next slide, I want to spend a little bit of time around the questions that each of those kinds of poses to us as engineers and technologists and strategists within our organizations. The first attribute we want to achieve is human-centered AI. This one might sound basic, but it really is a comprehensive area. We want to make sure that the end user, the end operation of that solution is in mind up front, all the way from ideation through completion, sustainment, and maintenance. We want to make sure that we have diverse perspectives heard. That might mean bringing together design interface folks and our engineers and our technologists, our statisticians, all kinds of other mission subject matter expertise may be appropriate as well. And we want to make sure that they're able to harmonize their ideas and their requirements together as we build these solutions up front. Robust and secure AI. We've spoken a little bit about this so far today. Obviously, we want robust solutions that are able to withstand different environmental variables, that are able to consistently deliver results that we can understand. If I have a model that's giving me a 90% level of confidence in an output, and it's not consistently delivering that with the same attributes, same factors in play, and is inconsistent, I'm probably not going to trust that solution, and it's probably not a robust solution. Similarly, security is of top mind and concern as well, right? As we think about secure solutions, we want to make sure that we're able to go through rigorous hardening, protecting and defending that solution, especially when we look at automation, thinking about drones in the mission space and the payloads that they carry. What happens when an adversary is able to retrieve that model or that algorithm, and what are the implications there? And then finally, scalability, really focusing on some of those solutions that we have and how we can grow them across the enterprise and the speed and complexity there as well. I'm just going to jump here a little bit in the interest of time to some of the challenges that we face in our AI next generation architecture. The journey to enabling our AI solutions is not easy, as I'm sure many of you realize from the statistics that we saw a little bit earlier on the rates of failure and so forth. We have a lot of different elements here that we have to reconcile, some old, some new. Things like reconciling disparate data formats, something we've talked about. Something that's a little more new, non-deterministic algorithms. When we start looking at, again, that idea of a consistent or single algorithm giving us different results for unknown reasons, that poses quite a challenge to try to understand. And that's a new area that we really have to explore and spend some time on. We also have quite a bit more development here around engineering solutions between legacy and new architectures. And we're going to dive into an example here in just a slide or two that really showcases that, particularly on using AI on an avionics platform with existing limitations today. There are a couple other considerations I'll mention here that I think are important and just to have on your radar, but we're not going to spend too much time on them at all today. Making sure that your organization has the right computing infrastructure and that optimization occurs as appropriate, trying to avoid vendor lock and having a successful acquisition strategy. And then also thinking about your talent. How do you make sure that your workforce has the skill set necessary to engage with these new technologies and to accomplish some of the tasks and functionality that are required when we use things like AI? And then finally, organizational change management. I'll be honest, a lot of these problems are not technology hard to solve. We actually do have the technology to solve them, but the cultural elements and the adoption, that proves to be time and again very much the challenge that we encounter across our different mission partners. Fear not, though, because with these challenges, there are ways to move forward. And some of those methodologies that you might want to leverage, again, borrowing from a lot of the work that we've done previously in software architecture, looking at the development of use cases to really understand a situation and the solution that is to be developed. The use of data standards, particularly in the open architecture space. When we think about different standards out there like open mission systems and CORPS and SOSA, and how we want to be able to use those to harmonize across services, across organizations, and really develop more robust solutions for joint contested environments. And the employment of encapsulation for disparate data formats, that's another example that we can look at here, particularly as we start thinking about transition architectures in those states. And again, back to an acquisition strategy of how do we focus on the borrow, buy, build mentality? We recognize that timeliness is critically important, especially in the national security space. The threat of 2030 is real, and we want to make sure that we are building our solutions in a timely fashion. And perhaps we can borrow from industry, and to some extent, we can buy solutions that are already existing, and then as a last resort, really build those that we need to have that are specialized and in-house. So we're going to spend some time here on these two, specifically attributes of data standards and then employment of encapsulation. So I just want to spend a minute here. This is what an existing avionics architecture at a very basic level could look like. Think of this just as an exemplar. We're running MIL standard 1553B on our data bus. We have data flowing. That MIL spec gives us the ability to connect up to 32 different devices on the bird. We have the limitation to transmit about 16-bit words of data, and simultaneous transmission by multiple devices is prevented. So a pretty basic environment when we're thinking about technology, right? This MIL standard, I believe, was established in 1978. It did have a little bit of an overhaul for 1553C a few years ago, but by and large, this is one of the environments that we tend to encounter quite a bit from an architecture standpoint. You see some of the different services here that are offered, our mission functions, more software services there, comms, PNT as our core capability, basic vehicle manage that exists. Not too surprising. Again, very much a rudimentary example of what we could see today. I want to transition that a little bit here to what we would see in an example next generation architecture concept for AI, in particular regard for an avionics system. So we see quite a bit of a different view in some ways. Instead of having that mil-spec standardization, we have an abstract service bus that exists, a critical abstraction layer, if you will, that's allowing different kinds of data to transist and be able to integrate with one another. And one of the mechanisms that we can achieve that in a transitory state is through encapsulation. So we can employ an open architecture standard, let's say open mission systems here, an Air Force proprietary open architecture standard that exists to be able to send these messages back and forth between subsystems and between different kinds of capabilities that we might want to employ. With that, we have renewed flexibility and freedoms that we didn't with the mil-spec 1553B. We now, instead of being limited in the 15-bit data messages, as well as just the timeliness of different messages to be able to communicate interactively, we're able to send things like open architecture messages, data transfers, special signals even, and security information exchanges. These could be messages that are based on an XML schema or another message format, and that is acceptable within this kind of architecture and configuration. I'm going to point out in the light bluish turquoise box here in the bottom left, we have this idea of a new capability. This is where the AI component comes in, of automatic target recognition. So you see in the first box, we have our SAR, our synthetic aperture radar, that's going to help persist that. In the middle, we have EO and IR. And then in the final box here, we have IRST. So here's an example of how we were able to employ potentially an AI capability, such as automatic target recognition, on an existing avionics platform using a new architecture, and not necessarily a future end state, but rather a transitory state, because we can employ things like encapsulation as mechanisms to be able to communicate with each of the subsystems here. You also notice this small stack below. This really represents our autonomy stack. So thinking of things like drones that we can employ, particularly the success that we've already seen with the Ukrainian conflict and the use of drone technology there, but that breakdown of perception, the localization and mapping that's required there, and the decision-making piece, particularly as we start to see more on the implementation side of software solutions that could exist in a ground collision avoidance software space or other kind of safety critical application capability that we could have. I'll just sort of pause here as we kind of transition into the tail end of our discussion and highlight this isolator that you'll see here for our safety critical and vehicle management system. In that transitory state, again, it's unlikely that our avionics platform in this example is going to have a system that's compatible with an open architecture data format. Because it is legacy, because of the cost and timeliness to really be able to achieve that, it may make sense to use a mechanism such as an isolator to be able to allow that subsystem to communicate with the overall architecture that exists here. And so that's one way that we can look at that piece. As we start to see the new bombers that come out, they already have an I-4, the bomber aircraft has that I-4 open architecture, and in fact will be incorporated in there. Just like a side note as well, it's important to consider the cybersecurity thoughts around having that kind of open architecture deployment too. So I just want to kind of wrap up for conclusion and leave a little bit of time for maybe some additional questions we might have here. But as we saw in that next generation architecture for AI, particularly that example for avionics, and again, please keep in mind, this is one example. This is one area for us to look at. There are going to be a lot of dependencies that exist based off your mission environment, your organization, what your objectives are. that are really going to dictate what that could look like. And so as we start thinking about some of the principles that you might want to have in your back pocket as we engage in this idea of a next generation architecture, the first three really exhibit a lot of the enablement that standards provide. So thinking about modularity, interoperability and reuse, rapid extension, modification, and replacement. Standards, open architecture standards specifically, allow us to achieve those kinds of capabilities. And those are principles that we want to make sure that we have, because that kind of integration is going to be so critical moving forward, particularly as we start to see information sharing and model and algorithm sharing goodness across agency, across organizations. The other two that are mentioned here, the organization of data. I think back to that question the one gentleman asked around, where does law come in? And we had that discussion around thinking about it up front and through the entire life cycle of development. The organization of data is really critical in that regard. We've got to make sure that we're doing a good job up front with collection. We're doing a good job of organizing and curating, and then ensuring the consistent cleanse and the consistent updating and timeliness of that data as it's used by our models and algorithms. And then finally, I'll just conclude with this idea of uncertainty quantification. We talked about it in a couple of different scenarios today, but perhaps this should be the number one principle here that we're thinking about for our AI solutions. Because if we don't have that kind of certainty and we don't have that kind of confidence, we're really setting ourselves up for failure, because we want to understand how accurate a solution or an output is, rather, that's coming from a system or a solution, how we can build that confidence and how we can influence it. And I think a lot of ways, the missing piece there is also the security of this. We want to make sure that as adversarial threat becomes increasingly critical and paramount, how do we make sure that we don't have unintended consequences of data capture, of data poisoning, and really the robustness that's required for our solutions to be successful. So Shane, I know we're getting near time. I don't know if there's any final questions that maybe we can dive into, or last questions that folks have.
Couple questions here, Mike, that came in here near the end, and we can jump to. Frank wants to know, what do you think of loose coupling as a measure to reduce complexity across processing chains?
I think that's where we really get into some of the pieces that we have out there around the data organization and why that's so important. I think about that as being an approach that we have to some of the different connectedness within architecture. I mean, honestly, there's definitely dependencies that we have to outline in more of a tightly coupled environment versus the loosely coupled environment. We could have that and see those kinds of instances. But something that we have to really figure out, I think, from the architecture standpoint, for sure. And one of the ways, I didn't mention it in that example that was shown, but we could look at that network environment as being InfiniBand. That's where we start getting into some of the loose coupling considerations, as we have that network fabric as being a mechanism to really help with that.
Question, comment from Doc asking, how can I get my firm involved in the next generation of architecture for AI document? Is there any collaboration opportunities?
Yeah, absolutely. We're happy to have those discussions. I think I have an end title slide here. Just share my contact information with folks. Happy to engage via email, probably the best way to just have that continued collaboration. Definitely welcome that discussion and opportunities for us to collaborate together.
Okay, we got about a minute left, Mike. One last one from Sushil asking, how do we define data, parentheses, type, format, scope, etc., in AI architecture? What role different departments or agencies have for the data to stay current and for the results to add value to the origin or ministry?
Yeah, it's quite a lift there, right? I think it gets back to the data ops discipline that we can have and being able to have all of those different roles together. We need to have data stewards, and those data stewards could be folks within the organization already that specialize in a different area, whether it's engineering or operator use. We need to be able to have those kinds of diverse skill sets brought together and perspectives to be able to craft good data that's going to be used. But ultimately, that's really going to be more of an organizational decision. How do you want to organize? What is the amount of data that you have? How is development occurring? Are you looking at more COTS-based solutions or in-house design that you're using? And how do you want to really build those teams together and have that interaction? The architecture concept is very much there to try to be that vehicle, that Rosetta Stone, if you will, to be able to have those different stakeholders communicate with one another and develop solutions and ideate. But ultimately, that's something that has to be an important part of your strategy going in, from the collection through the dissemination through the ingesting of the AI system. That's going to be hypercritical.
Mike, great discussion today. Thank you for sharing your expertise.
Thank you, sir. Pleasure speaking with everyone, and look forward to continued discussions and follow-up sessions.
And we thank you all for attending today. Upon exiting, please hit the like button below the video window and share the archive if you found value. Also, you can subscribe to the SEI's YouTube channel by clicking on the SEI seal in the lower right corner of the video window. Next, join us for our next webcast, which will be March 28th. Our topic will be how can data science solve cybersecurity challenges with Tom Scanlon, Matthew Walsh, and Jeffrey Mellon. Registration information is available on our website now and will be emailed out as well. Any questions from today's event? Please send to info@sei.cmu.edu. Thanks, everyone. Have a great day.